All right, so in this video, I'm going to be talking about intercepts of a linear function and specifically how we can use those to graph a linear function that is written in standard form. So standard form is when we see it looking like ax plus by is equal to some number c, where x and y are variables, and then a, b, and c are all integers. Um, and this is kind of an interesting property of lines. We did an explore on it in class, where we said one definition of a line is it's all of the points that satisfy some equation, right? Where you multiply a times x plus b times y, kind of the weighted sum of those gets you to c. Uh, and it's kind of an annoying form to work with. Like it's not immediately intuitive to most people what A, B, and C mean. So the easiest way to graph it is to figure out, well, if we want to look for any points that satisfy this equation, well, the easiest points to work with are going to be the ones where y equals 0 and where x equals 0. Those are also known as our x-intercept and our y-intercept. Right, so kind of the easiest way to graph in standard form. If we're looking for any point to satisfy this equation, well, let's set x equal to 0 and figure out what y needs to be, and then set y equal to 0 and figure out what x needs to be. And that will give us 2 points, and then we can graph it from there. So if we look at the graph here, we know that the y-intercept, that's where we cross our y-axis. So it's going to be this point here. So you can say y is equal to 2, or you can also say 0, comma 2. It's a point. And our x-intercept is right there. We don't know what exactly that x value is, right? It's not a whole number. So some fraction less than 1, I'm going to leave it blank for now, comma, we know the y is 0. So if we want to actually solve for this algebraically, well, we want to find the y-intercept. Well, we know that the y-intercept happens when x is equal to 0. So algebraically, we plug in 0 for x. You get 3 times 0 plus y equals 2. And that means that y equals 2, which is exactly what we found here. Right? It makes sense that that point satisfies the equation. And we can do, sorry, I should have put that over here for the y-intercept. Y equals 2, 0, comma 2 is the y-intercept. Now we want to plug in 0 for the x, or now to find the x-intercept, we want to plug in 0 for the y. So it's going to look like 3x plus 0 is equal to 2, meaning that 3x is equal to 2, and x is equal to 2/3, meaning that now we can see that our x-intercept is going to be located at 2/3, comma 0, and that's kind of what we see there. So in general, if you want to plot a point from, or a function from standard form, the process is you plug in 0 for x and solve for y, plug in 0 for y, solve for x, plot both of those points, and then you know the line is what connects them. So for the x-intercept here, I'm going to set 0, y equal to 0. So I'm going to get x minus 0 equals 1, meaning that x is 1, meaning that my point is 1, 0. And then over here for the y-intercept, I'm going to set x equal to 0. So we have x minus y is equal to 1, meaning negative y is equal to 1, meaning that y is equal to negative 1. I can put that there. You can connect those two lines. All right. Now, this one is a little bit more complicated. We can use the same process. So to find the x-intercept, we set y equal to 0. So we have 4x plus 0 is equal to 5. That means x is going to be equal to 5 over 4, meaning that our x-intercept is going to be 5/4, comma 0. Whereas our y-intercept is going to be 4 times 0 plus y equals 5, meaning y is equal to 5. Meaning that it'll be at the point 0, 5. And so we can plot those 2 points. Remembering that 5/4 is like 1 and 1/4, we can plot it at x is equal to 1 and then a little bit more. And then this is what that line is going to look like. All right, so that is page 6.